do it with matrix, and this isn't my calculator, so I was like, fuck, I gotta do it the long way. So I did it the long way. So like, 3 to 2, and then
I'm trying to line this thing up. So for the first time I watched the videos and I realized that thing focuses on that thing, not the stuff up here. And you can still read it, but I'm trying to, it's very weird.
yeah, that's why
I don't know.
what's the point of me trying if I'm not gonna get it right, and he's not gonna get it right.
I may have to go get markers. Here, I'm gonna go try to steal some markers. I'll be right back. I'm pretty sure I can see them.
The reason why he gives you partial credit is if you have the right answer, just not the right units or like the right ending or something like that. Yeah. Other than that, yes, he's gonna give you partial.
If it's 4 instead of 3,
Cause I don't even think if like you have the right like the right things worked out, and you have something wrong in your calculator, partial. Cause the way he did that one unit conversions from like 1,500 or like 4,000 something, where you went from kilonewtons per meter cubed.
that one I actually did make a mistake on. That was all on me, which was I did the conversion to feet and then I forgot to do the conversion from newtons to pounds. And I had the conversion rate written out. I just didn't do it.
No, I did the link from the unit link thing like he does, the square. I did that exactly the way he did it. I just guess I did it wrong.
That's so weird.
I got the wrong answer. I guess I forgot to do it.
So does anybody have questions about any of the homeworks, or should I just continue with what I was doing? I gave you, if you don't, I'll give you a minute. If you don't, I'll keep going with what I was doing.
Is there a certain question that's been hard?
For me, or that I've noticed?
Class.
Oh. My brain is not able to process. I don't know. I don't really know. See, he gives you a hardness number, but I don't know that's. I look at it and I'm like, okay, I don't know where he got that number. Like this was a hardness level 3 or something. And I look at it and I'm like, I don't know. So if I look at him, I don't know. So let's see. For some reason, the screen is really tiny here. So it says difficulty this course. It says 2221. There's a 3. He thinks, he being the guy there who came up with this, that this number 8 is the hardest. So I don't know. We can look at that one for a minute. It's very tiny though.
We're given velocity, acceleration.
Let me see if I can make this thing bigger. This thing is, I don't know why this is doing this way. So he thinks this is the hardest problem here. Okay, I really don't know. I'm not sure. So, half of it's off the screen. Okay. This whole thing is, you got 2 monitors here, and each one is vastly weirder than the other. Okay, he says car B is traveling. So since it's hard for me to read over there and then come back over. Car B is traveling distance D ahead of the car A. Both cars are traveling at 60. When driver of B applies the brakes, causing his car to decelerate at 12 feet per second. It takes the driver of car A 0.75 seconds to react. And he says this is normal time for drivers. I don't know. When he applies his brake, he decelerates at 70. Okay. So to determine the minimum distance needed so they avoid collision. So I guess this could be construed as kind of hard. So there's two specific time periods. I'll call them DT. So this is just basically you're driving along. This is before brakes are applied. DT1 would be a period in which he decelerates. Okay, his acceleration is equal to minus 12. His deceleration is equal to minus 17. And the delta T between these two is 0.75. Okay, well, let me just do it this way. Okay, so if you look at B, let's just do it this way. I guess I'm going to make the plot a little tinier. So what I'll do, this is kind of weird looking, but I don't know when to start the stopwatch except to start it in which it's basically going at, it starts at 0 when this guy applies his brakes.
Well, wouldn't we time the deceleration until we get to 0, and then add the 0.75?
Yeah. So what I was going to do is I was going to focus on B. So I was going to look at this being B, and then I was going to map him out. Like if this is time equals 0, then I was going to figure out how far it takes before he stops.
Right.
And then after I figure all that out, then I'm going to go back to this guy, and I'm going to, so since T is equal to 0 is when, so this is B. I guess I don't have much room, but I could do A right here. So A right here, this, what do you say, 0.75 seconds? So at 0.75, okay, I should have maybe moved that. Here, let me move that down to the bottom. So this is 0.75 seconds. And so what I was going to do, I don't know which one to do acceleration, velocity, and then position, or the other way. I'll do it this way, acceleration, velocity, and then position. And if that's the case, then this will be the same thing. And then I was going to focus on B, and then start with this guy over here on A, which maybe I should have done in reverse, but so at the initial part, they're both traveling 60. So there is no acceleration. So if you look back here, there's no acceleration. Gosh, I should have done that a little bit. And then all of a sudden, he comes down to minus 12. So he comes down to, this is ugly looking, minus 17? So it's minus 17 for him. So, you know, now I'm going to be the person in the room that's supposed to do, you know, here, I'll tell you, A is equal to dV, dt, you move the dt over, you got this, and dV, okay, what did he start at, 60? They both started at 60, okay. So this is 60, and if you go straight across, these are kind of clashing with each other a little bit. This is 60. It's okay. As you're doing this, you're going from 60, and instead of doing anything, I'm just going to say it's V. And then over here, I'm going to say 0, because at time equals 0, this guy's going 0. Okay, at time equals 0, this guy's going 60. And I don't know what that time is. I don't care right now. But I do know for A, it was minus 12. And that's all it is. So if I start looking at this, I could start, man, I made this thing way too small. So I can start to the point where I'm finding the point in which, okay, this is flat. Okay, when I mean flat, it's constant. Okay, and that means this is linear, and so it goes to right there. So if I'm integrating and trying to find this t, which I guess maybe I'll call it t b stop. I don't know. The time it takes b to stop. So if I integrate that, I'm doing the math here, but over there you just have to multiply height times, in other words, I have to do this times that. It should end up being, 5 seconds, but I want to do it over here to make sure. So if I integrate that, get 0 time it takes b to stop. Over here I get v minus 60. Okay, but then I got to put the t in here. I forgot to put the t next to that. T. So if you got an equation like this and you want it to stop, then what you get is minus 12 t takes to stop is equal to minus 60. Am I right? Is that TBS is equal to 5? Is that right? Man. So in other words, the area of this thing is supposed to be, 5 times minus 12 or minus 60. And so you get yourself to stopping at 5, after 5 seconds. So that's all good. It's like you're happy, okay, it's fine, I don't know. Over here, you got this, you go along, now you go to here. Now, without any knowing anything, okay, so if I did this, I guess I maybe need to finish this part up and do the S. So if I have this, okay, let me go back to this part. I go back to that part, and I move the 60 over, and I just leave this as a t, and I move 60, velocity is equal to 60 minus 12t. So this is for B, and if I put in 5, of course I get nothing. But the key is, I really want to be able to take this equation now. Of course, you should be able to do it visually over there, but I'm going to do it mathematically. And that is, V is equal to ds dt. And so I can take the t over and ds it. Now, my initial place is placed in which it's 0. And that's time equals 0. In other words, I put the ruler down like right there. And then the minute I put the ruler down, he hits the brakes right there. So I know where to put it and I know where to do the stopwatch.
Could we not just solve it geometrically?
Yeah, we can, but I just wanted to do it the math way and then.
Oh, okay.
Is that okay?
Yeah.
So I mean, you could, when you say geometric, you're talking about taking the area.
Yeah.
Well, I'm gonna do that way, then I'll come back and do this way. So as often as a person who stands up here, there's not very many people in the room, but I got to do however the many ways are, because one person in the room's like, I see it in math, but I don't see it. So I got to do this part of my job. I don't know what my job is half the time. Okay, so here, put S, and there I put a T, but now I inject this in here, and we'll come back and do it the other way too. So, here, integrate this, 60 minus 12t, that's a 12, dt, and that's going to give me 60t minus, integrate that, I think I just get 6t, right? Squared. T equal to s. Now this is beneficial because if I put, maybe I should write this right up here. So I'll say, this is for b as well. S is equal to, I guess the 60 in front would be just fine. Now, when did s become 0? I mean, when did, okay, what is s when t is equal to 5? Okay, I know I could calculate the area of the triangle, but I'm going to do it this way and then go do that and make sure I got it right. So I'll put in 5 seconds. 60 times 5 minus 6 times, I'll just put in 25. Okay, I don't know what that is. No, I hate to keep using, oh, I got the calculator up, so maybe I can do this for a change. 60 times 5 is 300 and minus 6 times 25. 150. So that's what it says, how far. Does that make sense? Okay, that's how far this went. Okay, let's see if that's the case. Okay, 60, that's the height of this thing, times 5 over 2. 60 times 5, okay, over 2, 150. Is that what I got to do? Yeah, so 150. Now the thing is, this is linear, so that can't, this can't be, it's got to be quadratic. Well, we already figured that out. And so, you know, you think about it, if I drew a straight line and I started deducting values from it, and so this is a straight line, this is values deducting from it. So it should kind of look maybe like that, I don't know. And that's 150. Now to me, what I would do is I would immediately go and put down another ruler. So this is a different ruler. So this, instead of S, maybe you want to call S with a funny thing on top. So it's different. So this is S, the funny thing on top, and this is S. So they're different because they have different rulers. I started by laying the ruler here, and then I'll figure out the D after I figure out some of that, so they won't hit each other. But luckily, the math looks exactly the same. I do not know, there's two things that could happen. The first thing that could happen is, okay, so he hit his brakes harder, 17 versus 12. One is this guy could stop and this guy could hit him after he stops. So in other words, you got the car, he stops and he hits him. Or they could hit before they stop. But the key is as long as we keep the distance above a certain amount, we're okay. And so what we'll do is we'll take this, we'll shift the distance, and then we'll put them back together. I don't know. So in this case, this A case, it's the same equation. 0. Yeah, this time I guess I'll call it TA to stop. But your acceleration looks funny. And this is integral from 60 to V dV. You started your time, your stopwatch before you ended up reaching this point. Now, you can do this geometrically and try to match the thing. I don't know, maybe we should do it that way first. So let's see. We're going to draw a straight line. We're going to say he's done there. So we'll go back and we'll say, how far is this delta t? I'll do it this way first and then do it that way. The other time I did it that way first and then I did it this way. That's supposed to look like a straight line, by the way. It doesn't really, does it? And so the area under that straight line, I'm sorry, the area under this, we want this to be delta t times 17 has got to be equal to 60. Now technically I should put in a minus 17 and I should put in, but it's okay. So I don't know. And he did not give me a number that would be a happy number. If it was 15, I might be a little happier. Did he not? Why would he not give me that? Anyway.
It's 3.5.
Yeah, 3.529, and I don't know why I was writing the wrong number. Okay, so I'll say that. Took him that long. Okay, and then what I'll do. Now the problem is, there's a problem here. I put the ruler here. So is this that? If this is this, and this is this, what should that look like?
Wouldn't it be the inverse? Wouldn't it, instead of the parabola being concave down, wouldn't it be concave up?
It might be. I don't know.
Since you're decelerating to 0.
The only reason I grabbed because I realized, oh, minus is 6. Yes, you're right. Because this is my mindset, believe it or not. Take that's the 60t, and then take this off. Wait a minute. So it has to, I don't know. So this would be 6t squared. It got subtracted from it. Okay, so that's the reason I did that. Is that?
No, that's not really good. Because the way that I think about it is that we're starting at 60.
Now we're talking about this curve, right?
Yeah.
Oh, okay.
It would concave down since we're going.
Well, wait. You mean what do you mean? You mean this?
I don't know how to explain it. I guess. I mean, mine just looks like this. Since we're decelerating. Oh, but since it is distance. Never mind.
Okay. Well, so the reason I did that one is I just looked at the math, and this is what happened in my mind. I drew a 60t, and then I got to take this off. And so if I put in t is equal to 0, I don't take anything off. And so as t grows, this thing grows. And so that's the reason I did it like that. So in my mind, I saw the math like that. The second one, or A, doesn't necessarily have that. And I got to fix something on that S over there. The S is goofed up on A.
Why did we do the 0.75 times 60? Because
yeah, that's where I was trying to fix that. So here's what I got. You got to find the area of that thing. Which what was it? 60 times. What'd you say? 60 times 0.75. Oh, what is that?
45.
45. Now, since that's a flat little short region, that should look like a straight line. And is it? So it's 45 at that point? Okay. So you're at 45. Then you start going down like that.
Right.
So since you're going down like that, since that does that same way, I'm going to assume it kind of goes like so, like that. How far out this goes? Okay, so in other words, this distance should be the area under that thing. Okay, so the area under this thing, I'll hatch it this way. That's ugly looking. So that is 60 because the height times the 3.529, and then only half of that. So I don't know. Oh, I had that up there. 60. right here, it's 3.5 to 105? 105, and I don't know, I kind of doubt those digits, but, because I threw away some, but it's okay. So then the question is, we already went 45. So how far did we go total over here? Okay, so, well, first over here, we went 150 and we stopped. Well, over here, 145, okay, so we went 145, no, okay. 45 plus 105, 87, is 150.87? This is a little bit bothersome because, well, I guess it shouldn't be. So this guy stopped right here at S is equal to 150. This guy stopped at 150.87. Now, is that correct? I don't know. So now I'm looking for the D between them. So if I make D 0, this thing, that can't be. So if they collide with each other right off, I mean, if they collide, or so maybe they're side by side. This guy slows down, and he hits his brakes, then he stops. In other words, it's kind of weird. Let's say you have A right here and B right here. So you look at it, it's possible that these are the same times. It's possible he could have hit him in flight. In other words, the guy hits his brakes, he could have hit him there, but if they were side by side, you know, they come back like that. Does that make sense? So now I'm a little concerned that he hit him right off. So if that's the case, and he's going 60, and he's going 40, he goes to, okay, he hits his brakes. You know, this is a difficult logic problem, because you can figure out the stuff, but then you got to figure out, did he hit him right off? Did he hit him, like, he hit his brakes and he rear-ended him before he was able to hit his brakes? So if that's the case, then that distance would be equal to what? Okay, so at 0.75 seconds, how far did he go? In other words, and t is equal to 0.75, the disposition of B would be, and we grab it from here, would be 60, 0.75 minus 6 times 0.75 squared. And if we did that, here, I'll be lazy. Let's see what it tells me. It says 41.625. So he has moved 41 feet. Yeah, moved 41 feet at that point. So he's still going 60. He's moved 41. Let's see now here's where
Yeah, they would have collided by that time.
yeah. So this is where I should have done the equation over here, but the equation between here and the 0.75 is fine, because he moved 45 and he moved 41. So in other words, at this point,
They would collide.
yeah, they hit each other. So I don't know, what's the difference between 45 minus 41.65? I don't know. 4 point digits. How about that? No. 3 point digits. 3 point with a lot of digits. So I think he would have hit them like right off. And then if they were side by side, you know, then you'd have a little bit more leeway, but, you know. So I actually worked more of the problem than I should have, but let's see what he says for available hints. I didn't even see that. What happens when you get that? Hint 1, how to approach the problem. First, identify the motion, the type of motion. Then use the unknown function prototype to write the position function. Identify 2 conditions that will allow, after the 2 conditions, I guess would be right off and then at the end. It's easy to find them and note that during braking, one car will change the motion type because of reaction time. 2 conditions. The worst case is a situation where there is no free space left behind the cars after their convergence, but there's also no collision. If car A is greater velocity than car B, it will tend to overtake B. Therefore, you need to find the motion car A loses its ability to overtake car B. I'm not sure I understand the logic of what he's saying there.
I think he's meaning, like, so when you were talking about the braking, so that 60 or that 0.75 second interval, we need to figure out like how much distance is needed between that, which is what you solve. And then after that, we need to find the distance between the area of the triangles on both sides.
Yeah. Yeah, so it's just hard to word something like that. So I read that and I'm like, okay, how do you word something like that? I don't know. So, yeah, so there's a little, I mean, the equation, you know, coming out with the equation of motion, you know, for like if you were just given A and doing this, that's kind of straightforward. But then throwing this in that you're trying to do that then you're breaking down to different situations that, okay, you can hit it right off. I guess, I don't know if this is the case because A is slowing down faster than B. But if it was not, in other words, if this was 12 and that was 17, it's possible that, you know, they could rear end each other like somewhere in here, you know. But I think because of this, we're looking at either that spot or this spot as being the rear end spot, which would be that spot is the same as that spot and that spot. So that's what he's describing as a problem that is hardness level of 3. So I don't know how he came up with these scores, the 2, the 2, the 2, the 1. I'm not sure I know how you come up with those scores. But that's on the problem sets. You know, in other words, I can look at them and see that. I haven't, I mean, maybe it's based upon, so since this guy keeps, the site keeps all the information, it's possible that what they do is they look at all the students across the country and they figure out their scores and then they rate them based upon that, maybe. I don't know. I don't know how you, I have no idea. So, and you know what? It really doesn't matter. Okay.
So would you be able to see the answer?
Oh, well, we could push that. Okay, now what was the answer we got? I could push it in there and see.
I don't think we ever did it.
Well, we got, wasn't it 4 point something?
Oh, I think that's the distance between the 0.75 interval. Like that's the minimum distance needed so they don't collide within that interval.
Let's just put in 4. How many digits? Oh gosh, 3. No, it was 3 point. What was it?
3.375 feet.
Let's just put it in. Uh-oh. Here, I'll request the answer. Are you sure you're not going to get any credits? 11 feet. So maybe I worked it wrong. Oh no.
Well, I don't think you did because they might have intersected
Oh.
after the 0.75.
Oh, okay. So I didn't complete it. Oh well. But anyway, did I give you enough information? Because I just erased it all.
A little bit.
Oh crap. Well, I didn't answer it very well. Well, yeah, that's right. I did. Okay. Anyway. See, I'm halfway useful. So is there any other things? What is this? Multiple particles.
I think we just have to watch the video.
Oh, okay. And then there's... Oh, okay. And then you... Particle A and B. Hey, maybe it says car A and B. Let's see. Can I just go like that? Oh, wait a minute. This is something... I thought it might be...
20
there's
feet,
a ball falling.
40 feet, and we are interested in the previous page. Write
And
the
so you
equation
must
for the
ask
ball
you
when it's
questions
thrown.
about
This
it
equation
after you get
for ball
done.
B, 1/2 times the time.
He's got to ask you
1.1
questions.
kinematics of
What do you think? Okay, so there's A and B, 20 feet, 20 feet. Okay. If I do away with that, it did away with the whole thing. Okay, so this is, what does standard view look like? Oh, okay. Car B is moving on. What? Oh, it's the same type of problem. Oh my gosh, it is. It's the same problem.
Maybe the video was like side by side.
I think it did, because when I clicked the video, yeah, it did. But wait a minute. Oh, okay, so one is ball A and one is ball B. Okay. So instead of car, it's a ball. Yeah, so it goes through the thing step by step. Now, does he give you, okay. Says he says velocity be 31. Is that actually what he's asking? And I don't know how to go back. Every time I do that.
He was asking for the minimum distance.
Oh, okay. Oh, okay, wait a minute. This is really weird. The look is very student data view. I don't know what that is. This is what you see. Okay, so it looks like what he did is he carried you through the velocities, and then you go one more step through the positions. Huh. So you know what I would do if I were you? I would work this problem before I work the other one. That's interesting. And yet a bit baffling. So it came back. Oh, okay. You got to make the page larger and you see it. Okay. Well, and this one had a number. What was the number of this one? Okay.
The answer to the video?
Well, in other words, okay, this is, oh, it doesn't have a number. Video solution problem. Where these had a number. I was just wondering if it was like 12, 14 or something, and it was actually back here. But I think I listed them. Well, I did not. Okay, there's 12.1, 12.7, 12.5? What? Did I put fundamental? Oh, fundamental problem, regular problem, and then the video part. Okay. I put them in clusters. I just saw the 12.7 and then 12.5, and then I saw 12.5 again, and I'm like, did I put the same problem in there twice? But apparently not. Fundamentals, I think, are supposed to be less complex. I guess that's the most complex here. Well, no, wait. Okay, wait a minute. This is 2. This is 1 and 1. So, well, just keep going along at this. I don't think I've opened, have I not opened the second? Okay, I don't know why I came in it that way, but I did. Open, it's not available yet, opens from the 12/29th. I mean, I could go ahead and open that one. I'll just go ahead and open that one. So let's see, adjust, okay. There is an edit dates. Let's do open. Due date available to students. How about I just push today? You know, in case somebody wants to start, just make it available. Now I'll just do that in the statics and the fluids as well. So that way it should show up in your list now. But I wouldn't go do it until I finish the other one, you know. It didn't change the due date. So, well, I could go back. Here, I'll do a reminder. What? I just said well, and it says a well is an excavation or a structure created in the ground by digging and drilling. Why did she know it? Why? I don't know. So let's here. This is just a quick 5-second review, just to embed this in your brain one more. And that's this. You know, here's your I, here's your J, and we focused on this. And it turns out that it's that. And then if you take the derivative of this, you get minus UR. So, in other words, this is equal to DUR dt as well, and this one that goes this way is equal to du theta dt. So it's pretty obvious. It's 90 degrees that way. So we'll just remember these, and the only reason I'm writing them is because I don't have time to pull out the whole set of equations. And what we'll do is we'll start off next time with this, because we did this. Wait. That was Friday, right? Did we do this? We did this Friday, right?
I think so, yeah.
Yeah. So we did this Friday. We did the homework. I'm reminding you of just these, because these are the key equations. The book has a really weird way of doing it. What he does, he says, here's UR, and here's UR at delta T, and obviously that's the difference between them. So then what he does there is he says, okay, after a little delta T, here's UR, U theta at a delta T, and here's U theta. So obviously it goes that way. So you can see why they're 90 degrees from each other. So if you just take a vector of constant length and you just rotate it that way, its change is basically perpendicular to it. Same thing here, you just take this, you move it a little bit, and it changes that way a little bit. So obviously you can see why as time goes by, this theta increases, this thing will just rotate a little bit. So the change basically is a vector that goes like that and a vector that goes like that. And it turns out mathematically, they're exactly that. And so what we'll do is we'll pick up with this, and you can look at the book if you want to. There's nothing wrong with it. The reason I do it the way I do is because I like to formulate UR as a function of I and J, and U theta as a function of I and J, because you can use that later on at times. This is okay. To me, you know, if you're kind of in a strange, sleepy state, you can accept that, and it's okay, but it's not as completely rigorous as this. And so we'll pick this up, we'll go through and figure out the velocities and the accelerations next time in polar coordinates, and we'll do some problems on that. So And for the time being, I think we can claim we're done. I need some energy, and I have brought some snacks for myself, so I may call it a day and then eat snacks, because I got to start in 15 minutes. Let's see.